Hello everyone. Today I am going to discuss logistic regression. In one of my last recording, I have discussed on the linear regression and also shown the demo how to create. How to create a model logistic regression. Sorry, linear regression model. So today I only discuss on the theoretical part, and next recording I'll try to give you demo. So in this tutorial, what you going to learn? First, what is logistic regression? Why do we need logistic regression? Classification versus regression. Why linear regression cannot solve classification? Logistic regression, institution and probability. Sigmoid function, decision boundary, cost function and gradient descent, training process, prediction process, and advanced. So, what is logistic regression? So, despite its name, logistic regression, you may think is a kind of regression model. Actually, not. It is a classification AI algorithm. Its job to answer the question like yes or no, spam or not spam, disease or not disease, loan approved or rejected, customer will churn or not. Okay, it's kind of binary classification, right? The suppose the bank want to predict whether a customer will default or not. This is a real example data. You can see the salary is 60K, credit score is 780, loan amount is this. So now the expected outcome is like yes or no, will default or not. So this is actually the classical uh, classification problem. Let's have a look. So regression versus classification. To understand the logic regression, we first distinguish between regression and classification. So regression actually predict the continuous values. Example, house prediction, house price prediction. It's output like 45K, around 5K, or any value is possible. Okay. So in classification, prediction predicts categories. Example, spam detection, as I said shown before, the output like spam or not spam. Okay, so only predefined classes. So say here the in classification, you just choose the predefined classes, but in regression, any value is possible. Let's detail in more details. Why cannot we use linear regression? Suppose we want to build a model to detect spam emails, but spam equals to 1 and not spam equals to 0. Actually, any algorithm return numerical value, not the any string or character. Okay, so numerical value on alphabet or string is this only return the numerical value like 10876 minus 1 2 minus 3 like that. So we have to actually categorize like suppose less than 0.5 is spam, sorry, not spam, and greater than spam like that. So here is an example. Let us suppose email length is 20, then spam no, that means value is 0, 50 no, 80 yes, 100 yes. Yes means 1, no means 0, as I said here. Okay. So our goal is to find out whether email is spam or not. We just we want to answer like yes or no. So inside an ML model, it calculates a score. For example, a linear regression model might prediction score like -8, -3, 2, 7. Okay. The problem is, can we say probability equals to -8? Impossible, because probability cannot be negative. Same way, can we say probability is equal to 7? Also impossible, because probability cannot be greater than 1. So a linear regression model may predict values like 1.8, -0.4, or 2.3, like that. So linear regression cannot guarantee that predictions stay within logical probability bounds like 0 to 1. So probability as a probability must be greater than equals to 0 and less than equals to 1. So that's why linear regression cannot predict. So here comes the another new function called sigmoid function. What is it? So we need a function that always returns a value between 0 and 1. Actually, sigmoid function transform the uh, numerical value, like in linear value like this, into probability value. Means it transform the value between 0 to 1. This is the use of the sigmoid function. The format is like that: probability equals to 1 by 1 plus e to the power minus z. But z is equals to actually weighted sum of features, the raw model score, and p equals actually our output probability. Okay. In next tutorial, I will discuss how internally calculation actually happens in logistic regression. So think of Sigmoid as a probability converter. It converts score to probability value like this using this formula. So large from the above value, this table, large negative score, you can see value almost 0. I mean, is falls under class 0, and large positive score almost 1, and around 0 that is uncertain. You cannot say that it belongs to class 0 or 1. That means, as I said, 0 mean in the not spam, and spam 1 means spam. So in that case, if the value around 0, so we cannot guarantee that this email belong to spam or not spam. So here sigmoid function transformed to the value between 0 to 1. It is no matter how large or small the score is. So okay, you understood. I hope you understood the use of the sigmoid function in the logistic regression. This is very important. And real life analogy, like imagine an exam with marks from -100 plus 100. The email model gives raw scores student A equals to minus 80, student B minus 20, student C equals to 10, student D equals to 90. These scores are difficult to interpret, right? Now, if imagine a teacher converts them into chance of passing, like score minus 80 is 0%, minus 20 12% chance, score 10 who got 70% chance, and who got the score 90 100% chance of passing. So teacher is doing exactly what the sigmoid function does. Okay. Now, why it is called S curve? Sometimes sigmoid function also called as S curve. Let's look at this graph. Here is a raw model score in the x-axis, and in the y-axis is a probability score. If we plot the value of probability and its respective model score, it will create a S-like graph. Okay, it looks like S kind of shape, like so. On the left, the probability stays close to 0, and around middle it rises quickly, it rises, and again is towards to the uh, near 1. Okay, so this smooth shape is why it is called sigmoid curve or S curve. So instead of directly predicting the class like spam, logistic regression predict the probability of spam. Let's say probability of spam is 0.95, meaning 95% chance that this email is spam. And for household example, suppose a bank calculates customer loan score. Now the bank have below can understand the prediction. Like suppose customer A model score is -7, and using sigmoid we transform this value like this. Okay. So from this data we can clearly understand this is a higher value. That means higher chance of getting loan than this, and then it's like this, and this is will not get any loan. Now let's discuss the decision boundary. What is this? How do we convert a probability into class? We choose a threshold. Usually the threshold is 0.5. Suppose if the probability is above 0.5, greater than equals to 0.5, it belongs to class 1. Or we can say like yes, fraud or spam. Actually, it's up to our us. We can decide. Okay, and less than 0.5 belong to class 0. Maybe no or not fraud or not spam, whatever. So threshold is 0.5. So based on the probability and our threshold value, we just predict fraud and not fraud, right? So model does not directly predict fraud or not fraud. It first predicts the probability and then compare it to the threshold, and finally it gives the output whether fraud or not fraud, like this. So let's have a look at training and workflow. How logistic regression learns. Suppose we have data like salary 20K, default yes, salary 50K, default no, salary 80K, default no. This is actually loan and defaulter kind of. The algorithm follows this step. Start with algorithm at random weight, then make the predictions, calculate the error, updates the weight using the gradient descent, and repeat until the error becomes very small. For now, you just theoretically know this process. Next tutorial, I will cover this because otherwise our recording will be very big, and it will be trouble for you to understand the things. Now come to the cost function used by the logistic regression, that is log loss. Linear regression use a mean square error. You can remember, you may remember, right? And the logistic regression use does not, or regression does not use, because MAC creates a default difficult optimization problem for classification. Instead, logistic regression uses a log loss or binary cross entropy. This heavily penalizes the confidence wrong prediction. True class or spam 1 or prediction 0.9, the base very small loss. True class spam is 1 or prediction is 0.99, very small loss. And 0.1, very large loss. I already discussed what is the use of log loss calculation, and again I will cover this thing in the next tutorial, so that you can completely understand what is actually happens. The complete workflow of it is a training workflow, the collect data, exploratory data analysis, feature engineering, feature scaling, train the model and evaluate. It's a prediction workflow. The threshold is a prediction for the probability value, and predict is a no default. So this logistic regression is a classical algorithm. We use classification metric rather than continuous error like MAC. Okay, we use accuracy, precision, recall, F1 score. Okay, confusion matrix, ROC, AUC. Don't worry, I will discuss all these things in the next tutorial. Okay, and now coming to the advantages and limitations. Advantage: easy to understand, interpretable, fast to train, produce actual probabilities, works well for binary classification, excellent baseline model. Limitation: assumes it's roughly linear relationship between features and log odds. Not suitable for highly complex nonlinear pattern. Sensitive to multi-collinearity, may require feature scaling. So why is logistic regression called regression if it is used for classification? Because it models the log odds of the probability using linear equation. The output is then converted into probability using sigmoid curve. As I shown above, actually it first generates the linear like value. Using the sigmoid function, it converts it to the probability value. That's why it's called logistic regression. First regression, then it applies the law. So how you can use this in the banking industry: loan approval, credit default prediction; in healthcare, disease prediction, cancer diagnosis; in e-commerce or retail, customer purchase prediction; in cybersecurity or email, spam detection, phishing detection; in telecom industry, customer churn prediction; insurance, fraud detection; in HR, employee attrition. So the difference between the linear and logistic regression: predicts continuous value, and here it is predicts the classes. Output can be any number. Output probability 0 to 1. Use mean square, where is log loss. Use D for regression, use for classification. Example: house price, spam detection. So final thing is that mental model is like doctor analogy. Imagine you are a doctor. A patient arrives with a specific stats: age, blood pressure, sugar level, and cholesterol. The doctor does not immediately say you definitely have a disease, right? Instead, the doctor thinks based on these measurements, there is an 80% chance you have the disease. That is exactly how logistic regression works. It does not directly predict the class first, it predicts the probability of the belonging to a class and then applies a decision threshold to make the final classification. So logistic regression is a classification algorithm that predicts the probability of a class using a Sigmoid function, then converts the probability into a final class level using decision threshold. So that's all for today. And in the next lecture, I will discuss the uh, different loss functions. Okay, how internally calculation happens in logistic regression. I will discuss.